Hey everybody, this is like a little supplement video to the presentation. You're going to see it in class from me. I'm going to go over it with you just to make sure that everybody understands what's happening. But I wanted everyone to kind of see this at the same time. So what we've got here is a series of energy sources. Okay, there's renewable, non-renewable, and then what we call inexhaustible. So your non-renewables are your classic fossil fuels, oil, coal, natural gas, and anything that's not one of those three is considered an alternative energy. Your renewables, sometimes called sustainable, because if we do it correctly, we can sustain these things and renew them indefinitely. If we don't manage our systems well, we can end up with a lack of one of the things that make these actually possible. Okay, so we destroy the environment, then we can't grow food, things like that. Inexhaustible are your hydroelectric, your tidal, your sun, your wind. Those things are not going away in the next millennium of time. So what I'm going to talk to you real quick about is some of these energy sources, like for example this geothermal one right here. We're just simply taking thermal energy from the earth and using it to do something else. We're either using it to heat, or we're using it to heat up water, to turn a turbine. We're doing something with this energy. So this energy source by itself is just that. It's just an energy source. It's just a storing, housing sort of deal for this energy. I want to talk real quick about this hydroelectric situation that we've got here. And I'm just going to make this picture a lot bigger. See if I can. Yes, here we are. So majority of our energy sources, at least to create electricity, are done in this manner. So in this example, we have a reservoir, we have an intake, we have something called a penstock, which is essentially like a big huge tube that the water flows down the tube, and you'll notice that it goes down a hill. You have gravitational potential energy behind the dam in the reservoir, and then the weight of that water, just simply the weight of the water, is falling and it's turning a turbine. A turbine is a fancy word for a fan. Okay? It's a really souped up fan. It's really supposed to be, really efficient. And what it does is it turns that fan is connected to a shaft, just like our VEX shafts, but hopefully not a square peg in a square hole. And it turns a generator. Now what a generator does, essentially, is it takes magnets, spins them around against other magnets, creating an electromagnetic field which moves electrons. Okay? And that's how we take gravitational potential energy from water, turn it into rotational energy, and then from there we can go and create, or not create, but transform it into electrical energy, because energy can neither be created or destroyed. It simply changes forms. So, for example, this turning of the wheel is basically most of your electrical generation that we see in this, at least in this part of the country and in this part of the world. We're talking about how are we going to most efficiently turn that wheel. Where was this picture? Somewhere around like that. There you go. So I have a quick little demonstration for you with this. It looks like a 1950s space toy or a Star Wars type deal. Essentially what's inside of here, I don't know how great this is going to show up on the video. You can see it better in person. There's a little tiny generator in there. Okay, it's a little bitty electric motor. It's essentially a series of magnets and coils and coils of copper wire. And when the magnets move, they create an electromagnetic field which moves the electrons in the copper coil and sends them down the wire. Okay, so if I was to take my electric generator there, my electric motor or DC generator, and spin the shaft inside of it. So I take my fingers and I spin it around. What can happen is it moves the electrons. Well, there's a little bit more efficient way to do that, and that's with these series of gears. Again, we just finished gears. So if I asked you to calculate gear ratios for this and gave you some information like the diameters or the teeth or something like that, that's something you should be able to do. So essentially what I'm going to do now is I'm going to take this and turn the crank on the generator. And you can see that the little LED is lighting up. And what that's telling me is that I'm actually moving electrons. I'm taking my I'm a renewable resource because I'm an animal. I'm taking my renewable resource and I'm converting it into electrical energy via rotational energy. Okay, we'll talk more about this as class goes on. So essentially, what's happening here is we're turning the wheel. Okay, we're either heating up steam, heating up water to make steam, high pressure steam, and we're spinning a turbine with that steam. We are using the wind power to crank this crank. We're putting big blades on here. We're putting this in the windy area so that it cranks a crank. We're using hydroelectric, the weight of the water to spin a turbine. I could become a generator and just sit here and spin this. Okay. However, I'm going to run out of energy eventually. I'm going to get tired, things like that. So keep in mind, all of these energy sources are just that. They're just sources where we're taking energy from wherever it is and we're transforming it into something else. Batteries are not an energy source. Batteries, if I scroll down here in this presentation, we can see that ways to store energy. Batteries themselves, and everybody says, oh, the battery, my iPhone, my iPad, my watch, my charger, my whatever. Okay, that's simply a storing mechanism. Okay, it's chemical potential energy being transformed into electrical potential energy. So when you're saying, oh, well, I'm going to use batteries as my energy source. Well, no. How are you going to charge the batteries? Okay, you gotta keep that in mind. So hopefully this helps and answers some of your questions. If not, please let me know, and we'll move on from there.